Every Git user knows the moment where switching branches becomes expensive. Git Worktrees solve that problem by changing one assumption. A repository does not need to have only one working directory. By the end of this video, you should understand what a worktree actually is, what Git stores in the shared repository, what Git stores per working directory, why branches are locked to a single worktree, and when worktrees are better than stashing or cloning again. I want you to remember that this is not a GitHub specific feature. Many real worktree workflows involve pull requests and remote branches, but the mechanism is built into Git. The cost of not understanding this is interrupted local state. It is rebuilding dependencies after another clone. A review can easily be delayed because your current branch has uncommitted work. In a small repository, those costs are annoying. In a large repository with long test runs or heavy local environments, they become part of the way the team loses focus. Worktrees were added to Git, so one repository could support multiple checked out working trees at the same time. The official command is Git Worktree. You can add a linked worktree with Git Worktree add, inspect active worktrees with Git Worktree list, remove one with Git Worktree remove, and clean stale administrative records with Git Worktree prune. Those commands might seem simple, but they expose a deeper Git model that is worth understanding before you make them part of your daily workflow. A normal Git checkout contains two kinds of state. There is the repository data, objects, commits, refs, branches, tags, and the history stored under the Git folder. Then there is the working tree state, files on disk, the index, and the current head. Most of the time those two pieces sit together, so it feels as if one repository equals one directory. Worktrees split them. The object database and most repository histories they share, while each linked worktree gets its own working directory and its own checkout state. That split is the reason worktrees are not the same as cloning the repository twice. A second clone duplicates the repository database unless you add extra sharing behavior. A linked worktree does not need another complete copy of history. It adds another checked out directory plus a small amount of administrative metadata. Now listen, if you commit from one worktree, the commit object exists in the shared repository, so the other worktrees can see it immediately. Uncommitted file changes are different. They belong to the specific working directory where those files live. When you run a command such as git worktree add, Git creates a new directory at that path and checks out the requested commit or branch there. In the main repository, Git also records administrative information under the worktrees area. In the linked directory, the Git entry is usually not a full directory. This is also why Git is strict about branches, and I'm asking you to write down this. In normal use, one branch cannot be checked out in two worktrees at the same time. If you need another directory at the same commit, use a detached worktree or create another branch. If you need to inspect a pull request, fetch the peer ref and check it out into its own branch or detach worktree instead of stealing the branch from your active checkout. The basic workflow is simple. From your current repository, run git worktree add hb hotfix. That creates a new branch named hotfix in a sibling directory. The hotfix directory has a clean working tree, its own index, and its own head. You make the fix, commit it, push it, and open the pull request from that branch. For review work, the pattern is similar. Fetch the remote branch or pull request ref, then create a worktree for it. Now your main feature branch does not move, your local changes are not stashed, and the review can have its own stuff. This is the main practical win. Worktrees turn branch switching into directory switching, while the repository history remains shared. There are a few workflows where this is especially useful. First, hotfixes. You keep your current feature untouched, create a hotfix worktree from main, fix the issue, and remove the worktree when the branch is merged. Second, pull request review. You can check out someone else's branch in a separate directory without disturbing your current branch. Third, bisecting or debugging old versions. A detached worktree lets you inspect a specific commit without moving your active branch. Fourth, parallel automation. If you run coding agents, code generators, or risky refactors, each one can operate in its own worktree so the dirty state is separated. The newer AI agent workflow is not special because of AI. Worktrees give each process a clean file system boundary while still sharing Git history. That means a process can build, test, and commit inside one worktree without using the same working directory where you are making decisions. And of course, worktrees can make a repository feel more complicated. You should not manually delete worktree directories as your normal cleanup method. Use Git Worktrees remove path. Also remember what is shared and what is not. Commits, objects, and most refs are shared. The working files, uncommitted changes, head, and index are per worktree. Dependencies, build outputs, and environment files are just files in a directory, so they are per worktree unless your tooling points them somewhere shared. That can be exactly what you want, but it also means each worktree may need its own install or build step. The clean mental model is this. A worktree is another checkout attached to the same repository database. It is a separate working directory with its own checkout state. Use worktrees when the work needs separate file system state, reviewing a pull request, testing a hotfix, running a bisect, keeping a long-running experiment open, or isolating an automation process. Use normal branch switching when the state is small and you do not need a second directory. Use another clone when you truly need a separate repository, separate remotes, or a fully independent local setup. That's it.